Hi, this is Ursh Pro of MakeWithTech. And no, this is not another filament-based 3D printer. It's not a laser engraver. It's unlike anything else we've reviewed on this channel before. This is a resin-based 3D printer. And what that means is that you have a tank of resin. Then you have an ultraviolet light that's shined from below the tank of resin. And by exposing points in that tank of resin, you solidify that resin. You'll see we have a build plate that comes down into the tank, and that limits the amount of resin that's exposed at any given time. The exposed resin adheres to the build plate moves up, and it exposes the next layer. Now, I've never reviewed a resin printer on this channel before, and the reason is that I tried to about 2 years ago, but I couldn't produce reliable results. This Mars 4 Max resin-based printer worked from the very first print. Now, not every print was successful. I had failures, just as you have failures with filament-based 3D printers. But I discovered that Elegoo has done a good job at producing an entry-level, relatively large, and we'll talk about what that means in a few moments, resin-based printer that they also provide with some other components that makes resin-based printing easier. So if you want to learn more about resin printing, how it's different from filament-based printing, what types of applications are the best applications for resin-based printing, stay tuned and let's learn something together. Here at MakeWithTech, we teach people about technology. We teach people how to use technology to make things. And we've also begun to teach people about the basics of technology. We have a new video about how self-driving cars work, how AI works. And in all cases, our goal is to simplify technology so anyone can understand it. Sometimes when you simplify technology, you might blur some of the details, and a purist might find the explanations not 110% accurate, but our goal is to empower you to use technology. So today, we're looking at the Elegoo new sort of set of products that are their entry-level products. It's the Elegoo Mars 4 Max, which is a good entry-level resin-based 3D printer. I'll explain why in this review. And the Mercury X kit, which includes a print washer and a print cure. Now, why do you need a print washer and a print cure? Well, what happens is when you expose the resin with a UV light, you partially set it because it takes a long time. So you could fully set it in this device by setting your times long enough, but your prints would take forever to complete. So you want to set it enough so it holds together. It's sort of like making a model out of clay. And then, in essence, you have to fire it. So firing it in a resin-based printing is called curing. There are actually two steps. First, since this was printed in a vat of liquid, you have to wash off all that extra liquid. That's called cleaning. And then you have to put it in a UV light source to solidify it or cure it. So the Mercury X kit includes a cleaning machine that rotates the solvent for your particular resin around that print to clean it off. And it has a timer built in so you can determine how long it's cleaning for. And then you have a curing machine that rotates the item once again. In this case, it's rotating it for the purpose of curing it by exposing it to UV lights, one on the bottom and two on the sides. Now, everything you see here, meaning these three devices, along with this bottle of resin were provided to me by Elegoo at no cost in order to do this review. I have purchased other resins. You'll see I've purchased a lot of other stuff because 3D printing with resin is more of an industrial process than 3D printing with traditional filament. First, let's just cover the specs. The Mars for Max. So it's a masked SLA resin printer. Its light source shines through a mask, which is just an LCD screen, sort of like a phone, where it can turn pixels on and off, clear or dark, in order to allow the light through. You're probably printing relatively small things on this printer, because printing something that's the full height would actually take quite a bit of time. One of the things that's very exciting about this printer, the new line of printers from Elegoo have built-in charcoal filters with replaceable filters, so they eliminate some of the fumes that come from resin printing. Now we'll see in a moment that I'm using a different type of resin. Classically, resin required alcohol for cleaning. Alcohol gives off a lot of fumes. As soon as I open up a container of alcohol, my air quality detector that I have here in the lab goes off. This resin really does not have much of an odor, and you clean it with regular water. So that made the whole process of 3D printing with resin more tolerable. They also include a license to the entry version of VoxelDance Tango software, which is a slicer. It converts your 3D object into layers for this printer. And in the case of resin-based printers, you're basically creating a slide. It's sort of an image for just a layer at a time. And then you're shining light through that image. This printer is available for $284 in a Prime Day sale on Amazon now. It's normally also under $300. Now, let's talk about 3 different types of stereolithography, which is the technical term for these resin-based printers. So basically, if we look at this printer here, and I'm able to touch this because I thoroughly cleaned it. One of the challenges with resin-based printers is even though this is water soluble now, you still can't touch it with your hands. You have to wear gloves all of the time. So in essence, the print is deposited on this build plate. This build plate is lowered into a vat, and then a UV light exposes that 0.05 layer of resin between the bottom of the print plate and the bottom of the vat. The material on the bottom of the vat is a clear plastic called FEP, and that's considered consumable. It will break down periodically, sort of like print surfaces and FDM printers, and you'll have to replace it. But the overall process, once again, is you fill this vat with your resin and you expose it to light from underneath. In traditional SLA, they use a laser and a series of mirrors to do that exposure. The next type is called DLP. DLP projectors are the types of chips that are used very often in conference room business projectors or even for movies today. It's a technology that projects an image. So instead of using a laser with mirrors to draw the image on the bottom of the FEP, with DLP it's projected all at once. Those were popular a few years ago. They're used in some high-end processes. Elegoo does have a DLP printer, but they're not all that common. The most common type of resin-based 3D printer for consumers and small businesses are masked SLA resin-based printers. In this case, that screen, the 9.1-inch diagonal screen we talked about in this printer, is once again just like a screen in your cell phone, except it's only monochrome. It's only black and white. And when you send a layer to the printer turns on black and white dots, cells, in that screen. Then a light from below shines through that screen, selectively exposing the vat of resin. Now let's think about it. What's really exciting here is it exposes the whole dimensions, the whole vat at once. So whether I have 4 or 5 or 6 or 8 things in this vat, whether I've covered the whole build plate or I've covered a single pixel, the exposure time is the same. In general, in round numbers, the exposure time for a layer is about 3 seconds. So if I have 20 layers to expose, that's going to be 60 seconds. Now, typical layer height used on many of these consumer grade printers is 0.05 millimeters. That's different than 0.2, so the layer height is much smaller. That's why the quality is so good. But for every one of those 0.05 millimeter layers, that's the distance between the bottom of the build plate and the bottom of the vat, I need 3 seconds. So to print a millimeter, which is 20 of those layers, it's going to take a full minute. So you could more or less measure the size of your object in height, and you would know how long it's going to take to print. Now, it sounds like this is a bit of a mess. So, and there's a lot of stuff here. Why do I want to do this? Well, the reason is outstanding quality. The layer height is 0.05 versus 0.12 or 0.15 or 0.20. And yes, you can get to 0.1 layer heights, double what you would do on this printer in some FDM printers. But you're still going to see the layer lines. The resolution of the screen determines the dot size. This is a 6K screen. If there are more dots, the resolution is higher. The dot size is smaller. The dot size on this screen is 0.034 millimeters. That's very small. When you consider a typical FDM printer is 0.4. This is 0.034. That's a tenth of the size of a typical FDM nozzle. Once again, you can get smaller nozzles, but you're not going to get as fine of a resolution. So the layer heights are smaller, the dot sizes, the XY is smaller, and the prints are remarkable. I can't read without putting on a magnifying glass this type on the back of this Benji. But you'll see on the screen, it is very visible. So the two advantages are very high resolution, and the speed of prints is not impacted by the amount of the build plate that you cover. What are the disadvantages? Well, the first is resin is a mess. It's going to get everywhere. Even though I clean this printer up with just water, the water that I clean it with can't be thrown down the drain because it has this resin mixed in. So I have to take the water, I have to expose it to UV light, and then pull out all of the cured resin. Now, cured resin is safe and you can just throw it away. But that water, what I've been doing is evaporating it, just taking it outside and letting it evaporate. Number two, tall objects print very slowly because you have 3 seconds per layer. Whether there's a little bit on the layer or a lot, it's 3 seconds per layer. Next, parts may not be as strong. It's a different process. The resins have a different strength profile. You're not going to get carbon-infused resin in a home-grade machine. Now, there are other types of 3D printers that use powders and other things using similar processes, more like these than FDM printers, that are designed for industrial use, but a home printer, parts are probably not quite as strong. When you have a failure, and you will have failures, starting up the print over again takes a long time. So first you have to take the print off, the part of the print that's on the print surface off. What probably happened is some of it delaminated and stayed in the vat. So you got to get that all cleaned out. The only way I found to be absolutely sure I have it cleaned out is to drain off all this resin. And when you drain off all this resin, you have to filter it through a filter before you can put it back with other resin. Then you have to clean it all off. You have to make sure there's nothing in here. You have to put it back in. It's a good 10 minutes. If you're doing everything perfectly, it's 10 minutes. So it is a messy, time-consuming process. But the end result, as we saw in this Benji, is remarkable prints. And we're going to look at some more together. Now, let's talk about all of this stuff. Because if you're going to do a lot of these, you need everything here. Now, if you're just using this once in a while, there are the supplies you need, except for the resin, right with the printer. So the first thing you need is a good pair of gloves. Now, it comes with disposable gloves. Remember, those disposable gloves, ideally, if they have resin on them, you shouldn't just throw them out. You should expose them to UV light first. I got these heavy-duty gloves. And I got them extra big because it makes them very easy to put on. And they cover all the way up over my watch. So they're very easy to use. Now, when I go to take them off, I have to first rinse them off with water, because otherwise I'm going to get resin on my other hand. So that takes me to the next thing I have here. I have a wash bin that I use with this process. So what I'll actually take and do is I have a sprayer with water, and I use that so I can use the minimum amount of water, because I'm going to have to figure out how to dispose of the water. I also, when I take a print off here, I take the print surface off. Before I put it in my washing machine, because I don't want to have to replace that water too often, I also will spray it down a little bit to get some of the extra resin off. In addition to these gloves, you probably should wear goggles, and some people recommend you wear a mask. Now, when I experimented with resin-based printers that use alcohol as the solvent, I found I needed to wear a mask. I haven't found the fumes have bothered me at all on this printer. But one of the reasons is this thing right here. This is an exhaust fan. This is an inline fan you can buy on Amazon, I don't know, 30 bucks. And it goes to a hose out a window. So the whole time I'm using this resin-based printer, I have an exhaust fan going. Now let's look at what else we need here. When you're going to empty the vat back into mix with other resin, you have to filter it. Now you can put these filters directly into this bottle, but I find they come loose. So I bought a little filter to hold it. Next, you're going to need a number of tools in order to get the prints off your print surface. Ideally, if you have the prints exposed just right, and I'll explain that statement in a moment, they'll come off with this little plastic scraper. Let's talk about that. Your very first layer you have to expose longer so it gets good adhesion to the build surface. So with this, you expose the first layer 30 seconds, and then every other layer about 2.5 seconds. I've increased that lately to about 2.6, 2.7. At that exposure, I did find that it was hard sometimes to get the prints off with this. My best tool, the tool I preferred for getting prints off print surfaces, is a single edge razor blade. Now, you don't want to put the corner down at all. You'll scratch this. In fact, scratches in this are probably a little less damaging than scratches in an FDM 3D printer surface. This print surface has a texture in it purposely to make it better for adhering to the print. But you put it very flat and you just get it up a little bit in a corner, and then I use a scraper. These two tools came along with a diagonal cutter, came with the 3D printer. Well, what else do I have here? I have a set of UV glasses. These are actually from a laser review I did. And the reason is, when you want to make sure your printer is working, there's a test image you can display onto the screen. And you look and you see if all of the dots have light in them. Well, you don't want to be looking at a UV light directly. That can damage your eyes, lead to cataracts, other issues. So you want to have a set of good glasses for filtering that light. Next, what is this? This is just a microfiber cloth, like the type you use for your glasses. And after you've cleaned out the vat to get it really polished up and perfectly clear, I found, and I saw this in another set of videos on YouTube, I don't remember which one, that rubbing it down, polishing it with a microfiber cloth works very well. And there are two more things I have here. The first is a pen with an eraser, or a pencil with an eraser on the back. Well, when my hands are in those gloves full of resin, if I want to touch the control panel on this printer, I don't want to get it full of resin. So I use the pen. And finally, a little trick that I've read about in a number of places, if you spray a little bit of WD-40 dry lubricant, the PTFE spray, on the FEP surface and polish it up, it'll help you ensure that your prints stick to the print surface, but not to the FEP. Okay, there's a lot of stuff here. So how do you go about starting a print? Well, the first thing you have to do is you have to level the print surface. And the way you level the print surface is really quite simple. You take off the vat. Many people say you shouldn't put it with this plastic side down. So I'm going to actually put it upside down over here. And then Elegoo provides you with a card that you place on the surface. The thickness of the card is the thickness of that FEP plastic in the tank. Then you go ahead and you loosen these two nuts here on the side with a Allen key provided by Elegoo, and you tell the printer to go to the home position. So let's just show you what that would look like. So you click on Manual, Home, and this is going to lower that platform to the home position. Now, two other things. It's important to loosen these nuts before you press the home button. Then once you started going down, you'll hear it beep. That means it's in the home position. Once it's tight, you make sure the four corners are down and you tighten this up. Then you check the card again, and right now the card's a little too tight. So I'm going to push on the 0.1 millimeter button, and I'm going to move this up a little bit until I can just move this, where it's tight but I can just move it. Then you return to the prior screen, and there's a button that says Set Z equals 0. I'm going to press on that. I'm going to confirm it. And we've now leveled our print bed. So now I can go back to Tools, Manual, and I can raise this back up, which I'll need to do in order to put the vat back into this printer. Now, the software that comes with this printer is different than the prior generation, the Mars 3 and Saturn 2 and the earlier printers from Elegoo. This ships with VoxelDance Tango. VoxelDance is a commercial manufacturing software company that makes very high-end software for resin-based and other types of 3D printers. Tango is their new offering for consumer-grade, hobbyist, small business printers. This printer is also now compatible with Chitubox, which was the slicer used in previous generations. I'm going to show you a quick demonstration now of VoxelDance Tempo, and I really like it. As you can see here, the VoxelDance Tango software is quite clean. To use this software, When you first copy it and install it off of the USB key that's provided by Elegoo, you'll find it will prompt you for a machine ID. So you go to the system info page on the front panel of your 3D printer, and it will give you a machine ID, a machine number, which is used to enable the entry-level license. The first thing you're going to have to do is go to Platform Definitions, and if you just click on the plus button here, you'll see a list of supported printers. Now, you'll see that this slicer is designed to work with a range of printers, including some very high-end machines. In our case, I selected the Elegoo Mars 4, and I took all of the defaults. But then the next thing you need to do is not quite as obvious. You have to click on the Resin tab, and then you have to click on Print. And then in here, and this is what's important, you have to fill in the exposure time for each layer and the bottom exposure time. Now, in the case of Elegoo, they publish recommended exposure times on their website for a range of resins. Now, to generate your first print, it's really quite easy. You click on File. You do, in the Pro version, have the ability to create parts from scratch. It's more or less a very low-end computer-aided design system, and to manipulate those parts quite extensively. In our case, we're going to just click on Open, and we're going to open this ring. Now, once again, you'll see the presentation is quite clear. You can use the scroll wheel on your mouse to zoom in and out. You can click on the center button to pan. You can click on the right button to rotate. So this is rather typical. Now, this is going to require supports because there's an open area here. There would require supports here. And the recommended procedure for resin printers is to tilt your object slightly and then add supports. And so we're going to take and click on Rotate, and I could say rotate minus 45 degrees, apply, and you'll see my object is now tilted. Now I actually want to tilt it in the other direction, so I'm going to tilt it in this direction also, apply, and we can see our ring is now on an angle. There's only a small area connected with the build plate, which is what we want. And the reason is that adding supports does not have the same cost in time for a resin-based 3D printer as it does for a filament printer. And the reason is that each layer's print time is exactly the same no matter how much you're printing on that layer. So to add supports, I make sure my object's selected. I click on Support Module, and then there are a bunch of different options. I'm going to click just Smart Supports for now, and I'm going to say Generate the Supports. And it's really quite fast. It will take a few seconds. And if you come from the world of filament-based printing, this will look like a lot of supports. But once again, adding more supports horizontally does not make any difference because it's only vertical height. So the fact that we took and moved this off the print bed by this height is the only thing that's going to add any time to our print time. Now, when we are ready to print this, we click on Slice and then Export Slices. We're going to want to select the GOO format, which is the format that this uses. Select where you want to export this to. It could be directly to the USB key, and click on Go. And that's all there is to getting started with basic slicing for the Elegoo Mars 4 Max 3D printer using the VoxelDance Tango software. Now, just to review very quickly, to make your first print, you fill the tank with resin. you put the cover back on. Why do you need the cover on? Because otherwise, all of that resin that's sitting in the tank is going to be exposed to UV light from the light in your room. That would be bad. Then you slice a print, you put it on the USB key, you put the USB key in the printer, you select print, you select it from the menu, you'll actually see a picture of the print, and you're good to go. Now, one thing you can do, because the most common failure on these printers is the first layer doesn't stick. Very common failure on FDM printers also. So after it's printed about 20 layers, which would be a millimeter, I'll sometimes pause it. That will raise the print surface up high enough so you can look underneath and see if it's sticking to it. Now at that point, it's only a millimeter thick, so you won't see a lot of detail, but you'll see if you're getting started correctly. Now let's talk about print quality. Now these rooks both came on the USB key that came with the printer. And what's absolutely remarkable is I took the STL file and I printed it on one of my FDM printers, a very good FDM printer. And it's an okay print. There was a lot of stringing, and I noticed that in the top there was no writing. Whereas in this print, there is writing. The writing is so small that the standard settings in Cura that I was using didn't even attempt to print it. Yet on the SLA or masked SLA resin printer, it printed just fine. So the quality of this print is remarkable. There's no stringing at all, lots of stringing here, and it's much clearer. But it actually took 3 times longer to print than this one. Now to be fair, this one was printed in an AnchorMate 3D printer, which is an exceptionally fast 3D printer. So I think comparing, let's say, Creality Ender printer and this printer, these would have printed about the same amount of time. Now the most common use case for consumers is they want to print miniatures, figurines, and they want them to have remarkable detail. This printer did a wonderful job, but they weren't perfect. I'm not even sure how these succeeded so well after that delamination, but you do see a bit of some flaws on the bottom. So this probably says that I had the exposure a bit too low at 2.5 seconds per layer, and I've since been experimenting with 2.7, 3.0. This Benchy, which came out spectacular, was printed at a 3-second exposure. Now, some other use cases that are excellent for these printers are jewelry. Now, if you're just printing cosmetic jewelry for the kids, you want to make sure, A, you wash this off thoroughly, and then you thoroughly cure it, because you don't want any resin on that. Now, you can feel that there's no resin on here. It's completely smooth. The detail in this ring is outstanding, and in fact, the detail in these charms are really very, very good. One of the ways these printers are often used is you can get castable resin. What does that mean? That's resin that you then cover in plaster. You put into an oven and the resin is burned out. Then you pour a metal, gold, silver, platinum into the mold, and that's how jewelers use these printers that have this remarkable detail to produce jewelry. Likewise, in dentistry and other areas of medicine, they're starting to use these printers in areas where you need a lot of detail. Now, not every print's going to succeed. I tried printing this flexible octopus and 2 of his legs stuck to the FEP on the bottom. Now, I didn't have enough time. I wanted to get this review out to experiment with different exposures, instead of putting it right on the bottom, perhaps it would be better to put it on a raft or some other type of structure. But just like FDM printers, you are going to need to experiment to produce excellent prints. Now, what are my conclusions? Well, if you need a lot of detail, then this is the way to go. Now you might need that detail because of a hobby you have. You might need maybe where you're printing items for dollhouses or items to go on a railroad setup, or you're into figurines and gaming, or you want to experiment with your own jewelry. And in addition to using these as for models for casting, you can also electroplate plastic. So I could electroplate this with gold, and while it would not be solid gold, it would look like gold. On the other hand, there's a lot of stuff here. So if you don't need fine detail, resin-based printers are probably not for you. They're probably not right in this form factor for traditional functional parts where finish quality is not as important. Overall, my experience with the Elegoo Mars 4 Max was outstanding. It's a very easy to use device, and while it does face all of the limitations of any resin-based printer, for the right use case, and I'm going to experiment with jewelry and some other use cases going forward, it's a remarkable device. When you combine it with the Mercury X bundle, you have a really full manufacturing setup that'll make it much easier to use resin printers. Thanks for watching this video. If you enjoyed it, go to forum.MakeWithTech.com, leave some comments there, leave comments below. If you liked it, give me a thumbs up, suggest this video to other people. Subscribe to MakeWithTech here on YouTube. Go to our blog at MakeWithTech.com. Have a great day, and let's continue to learn things together.